Okay, so we're going to talk about 1-7. We're going to solve linear inequalities. So we're going to learn to represent solutions of linear inequalities in one variable. We're going to use properties of inequalities to create equivalent inequalities, and we're going to solve them. And we'll use them to model real-life situations as well. Okay, so let's try an example then. Let's write this inequality to represent each interval. So let's take these interval notation and change them to inequality as per view. Should know how to do this. So let's give it a try. All right. So this means from -3 to I'm going to put x in the middle, and I want to not include -3, but I am including 5. So the closed bracket means including. This means -3 to infinity, which you don't need to write infinity. So we'll just write x is greater than -3, but we're not going to include -3. Sorry, x is greater than. You don't need to write the less than infinity. That's a given. Obviously, it can't be more than infinity. So, all right. The next one is 2 or 0 to 2. We are including both. So you want to do 0 is less than or equal to x, less than or equal to 2. In the last one, I usually just say all real numbers for that. You don't write negative infinity is less than x is less than infinity. Obviously, every real number is going to be between negative infinity and infinity. So this is kind of pointless. I just write all real numbers. I'm going to represent that as a solution. Any number works. All infinite solutions, maybe you'd say. When you solve an inequality, we're going to solve just like an equation. So we're going to subtract 3x from both sides. And this gives us 2x minus 7 is greater than 9. We're going to add 7 to both sides, and this gives us 2x is greater than 16. Divide both sides by 2, and you get x is greater than 8. So we can represent our solution like that, or we can represent our solution like this, 8 to infinity. We're not going to include 8 when you never include infinity either. So either one of these answers is fine. X is greater than 8, or all the numbers between 8 and infinity, not including either of them. I also want you to know how to solve absolute value inequalities. So what you do for these, you take what's inside and make two equations. So you do x minus 5 is less than 2. And you also do x minus 5 is greater than -2. So you change the sense of the inequality and you change the sign. And it doesn't matter what side you change the sign on. You could have changed the sign on this side by multiplying by a -1 and kept this positive. But obviously it doesn't matter, moving that -1 to this side is fine. So you take what's inside, set it less than 2, and then take what's inside the absolute value and do greater than -2. Now solve both those. Those give you your solutions. So you get x is less than 7, and then you also get, add 5, you get x is greater than 3. Now you need to figure out how to write this as a compound inequality, so it'll be 3, 7, x is greater than 3 but less than 7. So you can write this as a compound inequality, which means the word and would go here. And means intersection between these two intervals. So here's the solution. We can write that as an interval as well as 3 to 7, not including either. So either of these answers would work right here. All right, let's try another one. Same thing. Take what's inside and keep it the same to the right, and then take what's inside and change the sense of the inequality and the sign on the number. That's how you get your two equations each time. Subtract 3, and you get x is greater than or equal to 4. Subtract 3, and you get x is less than or equal to -10. Okay? Now, let's see. How are we going to write this? This one I cannot write as a compound inequality. Because if you try to put the small number first and the big number, and put x in the middle, x is less than or equal to -10, and x is greater than or equal to 4. So this one you cannot write as a compound inequality. So what you do is write the word or in between. And it might help to graph these in a line to see, because our solutions are x is greater than or equal to 4. So if I put 0 here, 1, 2, 3, 4, and then -10, 3, 4, 5, 6, 7, 8, 9, 10. So my solutions are closed circle at 4, closed circle at -10, all the x values that are greater than 4, which go this way, so all the values to the right, and then also all the values to the left. If I tried to do the word and here, which is intersection, there'd be no solution. So I have to use the word or right here to represent my solution. Two separate areas for my solutions. So basically, or means one or the other. So the solutions could be any number that's greater than 4, or any number that's less than or equal to negative 10 would solve this inequality. Okay, I guess the hardest problems you guys are going to have to do are when you have to write your own inequality from reading, because then you have to translate from English to math. So here's an example of that, and it's also an application problem then. All right, so you are choosing between two different cell phone plans. Plan A costs $49 per month, $49.99, and then for 500, you get 500 minutes plus 40 cents per minute, so 0.4 cents per minute. I'll write 0.4 times every minute. I'm sorry, let me back up a second. So if I'm writing cost, that's a better way to do this. It's $49.99 per month, plus I get 40 cents for each additional minute. So 0.4 times the number of minutes. This is plan A. Okay. Now the cost for B is $45.99 every month, plus an additional 45 cents per minute. And how many additional minutes must you use in 1 month for plan B to cost more than plan A? So we want plan B to cost more, so we're going to put a greater than symbol here. Plan B being greater. And we're going to solve for how many minutes we would use so that plan B costs more. So this is the inequality we set up. We just need to solve it now. So I'm going to subtract 0.4m from both sides. Give me $49.99 is less than $45.99 plus 0.05m. And then I'm going to subtract $45.99. And this gives me 4. Okay, and then I'll divide both sides by 0.5. This gives me m equals. Okay, so we get m equals 8. We get m equals 80. I'm sorry, it's 0.05 here. I'm making a lot of mistakes today. Divide both sides by 0.05 and you get n equals 80. So 80 minutes is when plan B would cost more. So basically that could tell you what plan to go with depending on how many minutes you use. Okay, hope this helps. We'll make a homework help video and go through a bunch more problems.